Degrees to radians and radians to degree, problem type 1. However, we get two questions where we're going from radians to degree. So what we know is we need to use a conversion factor. Very similar if you looked at 3, similar but a little different. And notice the thing that's a little different here is for the questions, they don't see round to 2 decimal places or 1 decimal place. And then also they provide a pi key. So if we were going from degrees to radians, we would want to keep that. So maybe we'll take a look at one of those, even though it's not listed here. Although, again, when you work this multiple times, that particular question could show up. We're going from radians to degree measure, notice the degree marker, we're going to use the converting factor of, again, we want to end up with degrees, so we have to divide out the radians. So we'll put the pi in the bottom and 180 degrees in the numerator, because this is a place where the two angles are equal, right? 180 degrees is the same thing as pi, just in a different measure, different units. So this, if you were to divide something divided by itself, we always get 1. So this really is a factor of 1. We're multiplying by 1. We take the angle we're given, negative 5 pi over 4. We multiply that by 180 degrees over pi. And then we just multiply straight across. But to make things easier, I guess as we're doing, if we have something in the numerator and denominator, same factors, pi divided by pi, that's going to be 1. So those will cancel out. 4 goes into 180. And I think that's where this one's a little more difficult. They want a reduced value. However, I'll show you. You could just take the 5 times 180. And then we're going to divide it by 4. And again, the end result is going to be degrees because those units carry over. And then don't forget this negative. I tend to do that sometimes. So what you can do, again, you could take 4 goes into 180 so many times. You can reduce this as we go, or you can just go to decimals, put in 5 times 180 divided by 4. And notice we don't have to worry about reducing because it ends up being 225. If it was a reduced fraction, let's say 3, 3 goes in there evenly, let's say 7. Notice this will allow us to click on this to get the fraction if we need to put it as a fraction, because it says, it wants it either as a fraction or as a whole number. So that's the nice part of decimals. But if it is a whole number, it just gives it to us, 225. So that's what goes in there. But negative, right? Because I forgot to put the negative on here. Negative 225. This does not have to do with coterminal angles. There's questions about those later, and they might want this as an, so this is just converting from radians to degrees. This is negative. Your answer should be negative. But I see students will mix that up and say, oh, I'll get the other angle, the coterminal angle that's positive, which is, it's equivalent, but it's not right. We want to convert this particular way of measuring the angle, it's a negative angle, into degrees. So let's go ahead and come down with the B part. Come here. We've got negative 2 pi over 3. We're going to multiply by 180 degrees over pi. And again, what happens, we just multiply straight across, but the pi will cancel with the pi. That's 1. So factor 1 comes out. 3 does go in 180. And again, you could do it all with your multiplication skills, or you can just say, well, let's plug it in here. Typically do this, especially on an exam, so that I'm not getting any mental errors as I go through this. Divided by 3, and again, I got the negative here, so I might leave it off. It's 120 degrees, negative 120 degrees. So I want to put that in here. And they've already got the degree marker. So that's how to do that one. Again, and I'll show you mainly because if we're going with this rate, if we were given, let's do a C part. Again, it's not here, but let's say C. What if they gave us something like 135 degrees? So if we want to convert this to radians, going from degrees to radians, we multiply by pi over 180 degrees, because it's going to divide out the degrees, right? So we get 135 pi over 180 degrees. However, this will reduce down. 5 goes into both of those, so you go through that. However, what I would do, a nice easy way to do that, is to come over here, type in 135 divided by 180. We get 0.75 as a decimal, but when we click here, we can get the fraction. It's 3/4. We didn't put in the pi, because if we do, we don't. Let's see if I do that. Yeah, see, it won't give me that option. So I don't put the pi in. I just want to get the fractional part. That's 3/4. That's what this is, times pi. So I can write this now, 3/4 pi. I can put it out to the side here, or I can put it up with the 3, and typically we put it up with the 3. So that's how we would have converted this one. And again, you could have figured out how many times, what the common factor that comes out of these. But it takes me several steps. I would divide both by 5, and then I'd see there's something else and keep going. However, calculator gets us the right answer directly without any mental errors occurring along the way.